everyone, this is Mrs. Morgan with 11.8 Rational Equations. At the end of this lesson, you will be able to solve rational equations. We're going to solve each equation and state any extraneous solutions. What is an extraneous solution? A solution that makes the denominator equal 0, aka undefined. The first type of problem that we're going to have is a cross product problem. And you're probably familiar with this. We're going to multiply on our diagonals. And what we have then is 7 times y plus 1 is equal to 3 times y minus 3. We'll go ahead and distribute that out. And we're going to solve this down. So we get a solution of y equals negative 4. And the question that we want to ask ourselves is, does y minus 3 or y plus 1 equal 0 when y is equal to negative 4? Well, no. So there are no extraneous solutions in this problem. The next type of problem we're going to solve uses least common denominators, and the least common denominator that we're going to be interested in is going to be between these two. So our LCD is x times x plus 1, or if we were to distribute it out, x squared plus x, and we're going to be using that over here. We're going to multiply each term by the LCD. So this term here, here, and here. And we'll do x times x plus 1 and x times x plus 1. And over here, I'm going to use the handy fact that if I distribute it, it's x squared plus x. And what I'm going to notice is that these are going to simplify out. So my x plus 1s are going to cancel, my x's are going to cancel, and my x squared plus x cancels. And that leaves me with 5 times x minus 1 times x plus 1. And that's going to be equal to 2. And now I solve this down. So my x is equal to 3/4. And again, the question that I want to ask myself is, if I were to plug in my 3/4, does x plus 1 or x equal 0 for 3/4? Well, no, it does not, so I have no extraneous solutions there. Okay, we have another least common denominator problem, and my LCD is the t plus 1 times the t minus 1. So each term up here is going to get a t minus 1 and a t plus 1. And when I have this, what I'm going to notice is that things are going to simplify. So my t plus 1s are going to go, and my t minus 1s are going to go. And my t plus 1 and my t minus 1 are just going to stay here. So what I have is the 2t times t minus 1. I have, smaller eraser. I have my 4 times t plus 1 right here. And then I have my 2 times t plus 1, t minus 1 right here. And we're going to multiply all of that out. So 2t squared minus 2t plus 4t plus 4. And I think we're going to do this in 2 steps. So we'll have 2 times t squared minus 1t plus 1t minus 1. And that's going to get parentheses around it. Now looking closely at this, my minus 1 and my plus 1 are going to cancel. And so I have, if I were to distribute my 2 to my remaining, I have 2t squared minus 2. And if I were to clean up the other side, I have 2t squared plus 2t plus 4. And when I solve that, I get an answer of t equals negative 3. And the question again that I want to check is, does my t equals negative 3 make either of these things equal 0? It does not, so I have no extraneous solutions again. Finally, example 3, we get to see what an extraneous solution is going to look like. The first thing that I want to notice is that my n minus 5s are a common denominator. So I'm going to combine my like terms up here. So I'll have 6n minus 30 equals, over n minus 5 is equal to 5. And I'm going to multiply both sides by n minus 5. And on this side it's going to cancel, and on my other side I'm going to have (5n minus 25). So when I solve this down, I get n is equal to 5. And I want to check, does n equals 5 make my denominator equal to 0? Well, yes it does. So finally we have n minus 5 is extraneous. So what your answer should look like would be no solution, because there's no solution that works. And then we say that our extraneous solution is 5. And that's your lesson on rational equations. Please let me know if you have any questions.